Alright guys, took a small break and now I'm back at it. Second video of the day. Let's get it done. Quadratic graphing practice. This should theoretically be our very last video of 2021. So, well, maybe I'll make a fun video or something video game related or whatnot. But anyways, let's get going. So we are trying to graph it, and this is a lot of stuff that we have to figure out. We need to figure out all the zeros, the y-intercept, the axis symmetry, and at least 5 accurate coordinates. So there's a lot of stuff that we got to do on these questions to make sure that we have every single part of them done. We're trying to graph these as neatly as possible. Let's get it done. So step one, I gave you in the notes there. We're going to set this guy equal to 0. What you are figuring out is what's called the x-intercepts, the places where the y value is equal to 0. So we're making the y, the f of x equal to 0 there. We factor just like we've been doing in class for quite some time. That's x minus 5 and x minus 1. Because you're figuring out the numbers that multiply to 5 and add to 6. Like, 1 times 5, only numbers that work, -1, -5. Okay. Anyways, we have x minus 5 equals 0 and x minus 1 equals 0, and therefore x is equal to 5 and x is equal to 1. So at this point in time, I'm going to start my x and y table. Maybe I'll do it in a slightly different color just so it's very clear that this is like off to the side in the question. F and f of x, and let's also make a line down here so I can clearly have a 7 part of that question. Okay, now we need 5 coordinates. So that's 1, 2, 3, 4, 5 coordinates available now. And we're going to put these two always here. So we have a 1 and a 5. And when x is 1 and x is 5, we have figured out that the y value is 0. Right. Beautiful. Continuing on, our step number 2, we find the axis of symmetry, the middle part. So this is all of our step 1. Our step number 2 here, we're going to take those two numbers that we just found, add them up, and divide by 2. 6 divided by 2, 3. And now we have to take that value 3 and plug it in. So step 3 requires us to plug 3 back into the original equation. Here we go. We get -9 plus 5 gets you -4. Easy enough. Now, step number 4 is kind of off to the side. It's nice and simple. It's the idea of plugging in 0 for x. So when you plug in 0 for x, you get 5 for y. Likewise, on the opposite side, we're going axis of symmetry concept. So here's our vertex, that middle value that we just found, 3, -4. And if I were to go on the x values here, it would subtract 3. And going on the x values here, we're adding 3. It's going to give you 6. So it gives you identical y values because it's perfectly symmetrical. And now we can create our nice, beautiful little graph. So we've got 0.5 is off the graph, 6.5 off the graph, but the other values are all on the graph. So we have 5 and 1, 3, -4 would be down here. And you could figure out some more coordinates just to make it nice, neat, and beautiful. If you really, really wanted to. So you could plug in 4 and see what you get. But if you did plug in 4, you would end up right here at -3. 16 minus 24 plus 5 is going to give you -3. So you could plug in some more coordinates to actually figure those out. So if you wanted to see the work for it, you could off to the side. But point is, so we have these, and I would have given you credit because you wrote these down over here, but you really want to make it curvy when you go up. You will no real straight lines, all curvy, no edges. Actually a very important idea about polynomials. They are smooth, curvy, not rough and edgy. All right, continuing on to number 2. Same concept. Let's get it going. So we got our 0 is equal to x squared minus 8x plus 15. So factoring that up, that's going to give you a -5 and -3. I gave you some easy ones here, it looks like. So you get that -5, -3. So x equals 5. You can notice I'm skipping steps now, getting lazy. We got our x and our f of x values. Here we go. Boom, 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 boom. Here we are. So we have a 3 and a 5. And this one's so easy to figure out what's in between 3 and 5. What's smack bag between 3 and 5? That's 4. We don't even need to show the work on this one. Nice. We get zeros here. We do need to plug in 4, though. We do need to show the work for that, unfortunately. 4 squared minus 8 times 4 plus 15. So we got 16 minus 32 plus 15. That should be a -1 in the end. Figuring out some more values. If we plugged in 0, we'd get 15. That's subtracting 4, so adding 4. 8 will also give us 15. We might want to figure out some more values too. You could plug in something like 2 into the question. If you plugged in 2 into the problem, what would you get if you plugged in 2? You get 4. This is -16, -1, 3. So just to give you another idea, 2 comma 3 is going to work too. So anyways, we have 3 comma 0. We have 5 comma 0. 4 comma -1. And then sure enough, right here will also work. Now you might have noticed a pattern here. If this number is a 1 in front, if you notice, the first coordinate was 1 box away, and the next coordinate was 3 boxes away. And guess what? The coordinate after that, at 6, is 5 boxes away. And then at 7, it would be 7 boxes away. And then at 8, it'd be 9 boxes away. It always adds 2 extra boxes as you go up. So that's an important concept we'll talk about a little bit later. More when we get back from break, actually. Anyways, there we go. Good enough. Continuing on. Number 3. So number 3, actually even easier to do because some of the values are nice and simple. The only problem is that we're not going to be able to find our extra coordinates without plugging things in. So let's talk about 0 equals x squared plus 2x. Factoring here, we're going to get x times x plus 2. Therefore, x is equal to 0. And x plus 2 equals 0. So x equals -2. I'm making that chart up off to the side again. Boom, 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 boom. So we have, like I said, we have 0, 0, and -2, 0. So this 0 there, this 0 there, -2 there, equals 0 there. Okay. Now the problem here, oh, and vertex. Vertex is going to be 0 plus -2 divided by 2. That gives you -1. This is our x value. That axis symmetry, that vertex. Oh, I didn't draw my axis symmetry in the last 2 graphs, did I? So you got to draw the axis symmetry in. Axis symmetry is smack dab down the middle. And our y-intercept, by the way, is this guy. That's our y-intercept. Y-intercept. And smack dab in the middle there is our axis of symmetry. If we want to like label it more precisely, we could write like AOS. X equal to 4. It's actually good practice to get into. So, and I'm going to write it down here, and then like 0, 15 is our y-intercept, just to have it. Just to have it. Same here. AOS x equal to 3, and the y-intercept, we got 0, 5. Anyways, back to here, -1. Now we can actually just draw in our y and our axis symmetry right away. AOS is x equal -1, and our y-intercept. Now here's what's confusing. Our y-intercept and x-intercept are the same. It says 0, 0. So actually going to cause a problem for us. Did I say I need to find the vertex on these two? I should have said vertex on this, but I didn't. Didn't require the vertex. I should have. Well, whatever. Anyways, we have -1 here. Plug in -1. We're going to have f of -1 equals -1 squared plus 2 times -1. 1 minus 2 is also -1. This is a weird parabola. I gotta say, we have 0, 0. We have -1, -1, and -2, 0. So using that visualization skill from the previous page, if it goes over 1 on the first one, it's going to go up 3 on the next one. So just to verify that, let's see. Let's watch the verification that that's true. If I were to plug in 1 into my equation, because I got a 1 down there, I'd have 1 squared plus 2 times 1. 1 plus 2, that gives you 3. There's your verification. Same thing would happen over here. Not even going to bother verifying it. There's my 5th coordinate. Boom, boom, boom. Please note that does not work if there's a number in front, but there's not a number in front for any of these, right? Easy enough. Let's do it. Let's do this one even a faster pace. 0 equals x squared plus 4x plus 3. We factor right away. X plus 3, x plus 1, x equal -3, x equal -1. Obviously, between those two, we have our axis of symmetry is x is equal to -2, smack dab in the middle there. X, f of x. Boom, 1, 2, 3, 4. Okay, oops, a little bit lower there. We have -1, comma 0, -3, comma 0. We have -2, comma whatever we got to do to plug this in here. F of -2 equals -2 squared plus 4 times -2 plus 3. You got 4 minus 8 plus 3, -1. All right, so we have -1, comma 0. We have -2, comma -1. We have -3, comma 0. Oh, I never found my y-intercept here. Oh, yes, I did. Y-intercept here, we can actually plug in 0, comma 3 here. And again, it's whatever this value is right there is always our y-intercept. And if we go up here by 2, or we subtract by 2, you'll get exactly the same y value. So we got -4, comma 3, or you could have used that visualization skill. As you can see, there are a lot of ways to do questions like this. A lot of ways to think about it. It's a key concept in math. There's a lot of different ways to do it. Continue on. We have a few more to graph. Uh-oh, that said 3, comma 4, and this jumped to 7, comma 8. Oh, my printer. I blame the printer. So this one I threw on there just to be kind of nice about it. I've actually already given you this problem before. It's f of x equals x squared. There's no factoring to do. There's nothing else. This is actually straight from your notes from way back when. This is a mother function. Right here we have AOS is x equal to 0. Our y-intercept is 0, comma 0, and we already know these coordinates. 0, comma 0, 1, comma 1, -1, comma 1, 2, comma 4, -2, comma 4. This is exactly the same graph that you already have in your notes from way back when. So it's coming back at us again. There it is. Number 6. So this is our first one where there's a 2 in front out here. That 2 in front is going to cause problems for us. It's not going to follow that same exact beautiful little pattern of 1 and then 3. So we have to do a little bit of extra work. This one, let's take our time. So I gave you a freebie here, not a freebie here. So here we go. So 0 equal to this guy. And we're gonna have to factor this one. The factoring it requires us to pull out a 2. Just like this. Continuing on, we have to figure out what multiplies to 8 and adds to -6. That turns out to be -4 and -2. And then now we have x minus 4 equal to 0, x minus 2 equal to 0. So x is equal to 4 and x is equal to 2. I'm going to go ahead and kind of do this. So we have x and f of x here. And that means we have a 2, comma 0 and a 4, comma 0. Just to repeat it, we figured out these two coordinates are x's for when y is equal to 0. Then we need to figure out what number is smack dab in the middle of those. I'll actually write out the work for us, even though it's super obvious that smack dab between 2 and 4 is 3. Now we have to plug the 3 back into the original to figure out what the vertex is. So here we go. Let's plug that in. So we're going to go f of 3 is equal to 2 multiplied by 3 squared minus 12 times 3 plus 16. Doing the work, 2 times 9 minus 36 plus 16. That's going to be 20 minus 20. Wait, 18 minus 20. I was getting ahead of myself because -36, 16 is -20. And you get -2. So that means we have 3 comma -2 as a part of our graph. And then we have a 0 comma 16 as an accurate coordinate because the original graph has that 16 out there. And if we were to go down by 3 here, we would also get the same as going up by 3 here. which is to 6, sorry, adding 3. That will also give you 16. Personally, I think it's a good idea to plug in 1 and 5 here so we can get a nice, neat little graph. So let's do that as well. This is not technically a requirement, but they will have the same answer either way. If I were to plug in 1 here, f of 1 going down on the page here. So we're going to have 2 times 1 squared minus 12 times 1 plus 16. That's going to give us 2 minus 13 plus 16. That is negative 11 plus 16. And that's going to give you 5. So both of these guys turn out to be 5 by symmetry. Putting this all together to make a beautiful little graph, we got 2 comma 0. We got 4 comma 0. We got 3 comma negative 2. We have 1 comma 5. And this is what I meant. You see how it goes over 1 and then up 2? And then over 1 and up 1, 2, 3, 4, 5. So totally different idea there. You added 2 and then you added 3 more on top of that. So unfortunately, the kind of pattern there that we liked before doesn't follow as well. But it will still be symmetrical. And now we just make it as curvy as we can while we go up. We draw in our axis of symmetry. X is equal to 3 is our AOS. Our y-intercept there is going to be 0, 16. Really not much else we can do. Last 2 problems, let's get them done. Number 7. So here we go. We have negative 2x squared plus 4x and this negative x squared plus 6x minus 8. These guys are a little different because these are upside down. Whenever this guy in front is a negative, we have a frowny face parabola. So these guys, if you have a happy letter A, you get this guy. And if you have a frowny letter A, you get this guy. That was part of a little notes we drew at one point in time. So let's hop to it. Let's see what happens on this one. So same idea to start. 0 equals negative 2x squared plus 4x. We're going to factor out a negative 2x. Then we have negative 2x equals 0, and we have x minus 2 equals 0. So x equals 0, and we divide both sides by negative 2. And add 2 to both sides. Going to give you x equal to 2. Starting off our set of coordinates, let's get going on it. We have x and f of x. And there we go. We have 0, 0, and 2, 0. And again, I think this is nice and obvious. Between 0 and 2 is a 1 right away. And plug in a 1 here. If you plug in 1 into this guy, f of 1 is going to give you negative 2 times 1 squared plus 4 times 1. Negative 2 plus 4 is a 2. We already have our axis symmetry then. Our axis symmetry is x equal to 1. Our y-intercept we also have is 0, 0. So we will need to plug in another value. I think it's nice and easy to plug in, say, 3 or negative 1 because it's kind of the next guys. And those have the same exact value for both of them. So if I plug in f of 3, it's going to give you negative 2 times 3 squared plus 4 times 3. That's negative 2 times 9 plus 12, negative 18 plus 12 gives you negative 6. So that means these are both negative 6 right away. And now we can make a nice, neat little graph out of it. So we have our axis symmetry at x equal 1. We got 0, 0. We have negative 1, negative 6. We have 1, 2. We have 2, 0. We got 3, negative 6. There we go. There we go. Beautiful. Last problem of the night. Let's do it. Same idea. 0 equal to negative x squared plus 6x minus 8. So in this one, you have to realize that you're able to factor out a negative 1. That's the hard part about this one. So x squared minus 6x plus 8. It actually has the same exact vertex or same exact values as the previous question. Minus 4 and minus 2. Continuing on, we have -1 never equals 0, so x only equal to 4, and x is equal to 2. So again, smack dab in the middle of those two, I don't need to show the work, and middle of 4 and 2 is 3. So that means that's our axis of symmetry. So we have our AOS at x is equal to 3. We have our y-intercept at 0, -8, which is going to be off the graph. So we have 2, 0, 4, 0, 3, 0. Good idea to plug in maybe a 1 or a 5. If you're to plug in 1 into this, -1 plus 6, that's +5, -8, that's -3. I don't know why I wrote 0 here. Not 0, if you plug in 3 there. If you plug in 3 into the equation, let's see what happens when you plug in 3. F of 3 is going to be negative of 3 squared plus 6 times 3 minus 8. That's -9. That's 18 minus 8. That's going to be +1. So anyways, you get 3, 1, 2, 0, 4, 0, 1, -3, and 5, -3. There we go. Beautiful graph. Have a wonderful winter break, everyone. Enjoy your time with your family. Enjoy your time without having to do math. And I really wish you the best. And I look forward to teaching you in 2022. Peace out, guys.